After retiring Bertha, the world's largest tunnel boring machine, the United States secretly began working on an even bigger TBM to build a groundbreaking transportation structure kept hidden from the international media. The project continued underground, with citizens only noticing dust clouds and hearing loud noises. After a thorough investigation, the identity of America's mysterious giant TBM has been revealed. How massive is this machine? Join us in this special episode as we uncover the American secret that can drill through a mountain in a day. The Ash Wednesday Incident. On February 28, 2001, in the early hours, Seattle was struck by an earthquake of 6.8 magnitude on the Richter scale. Houses trembled, pavements split, and one of the crucial transportation arteries of the city, Alaskan Way Viaduct, sustained severe impairment. The event is called the Ash Wednesday Incident, and it lasted only 45 seconds but showed the vulnerability of the infrastructure in the city. The viaduct was still old and worn, and another earthquake could bring the structure down, affecting the city's economy. About 110,000 vehicles pass through the viaduct daily, and closing it would result in heavy traffic jams. Repairing or replacing it was unimaginable as it would take years to congest again, which meant a new approach was necessary. The concept of creating tunnels below the city was suggested as a method of minimizing interruptions on the surface, but constructing a tunnel under an excited town took work. City planners and engineers developed a plan of attack that called for building a giant tunnel boring machine, TBM, to accommodate Seattle's varied and inconsistent subsoil, ranging from sand to hard clay. This led to the construction of Bertha, a TBM named after Bertha Knight Landers, the first woman mayor of Seattle. The Ash Wednesday incident showed that Seattle's infrastructure needed more than temporary fixes. A tunnel was a long-term solution to withstand future earthquakes and modernize the city's transportation system. Thus, Bertha was born to tackle the challenge. After Bertha was manufactured in Japan, it was disassembled for easier transport and shipped to Seattle, where it was reassembled. The machine was too large to cross the sea in one piece. Bertha weighed in with a 4 million pound cutter head, slurry pipe, shield, control room, and trailing gear. On July 30, 2013, engineers began working with Bertha under the watchful eyes of international media. The tunnel boring machine started digging through a cement plug, aiming to break through to the other side of the city center within 14 months. While the digging process appeared routine, Bertha was about to encounter dangerous obstacles that weren't rocks or clay. What indeed caused the downfall of Bertha? Was it just the weight of time and progress, or was there a deeper story? The fall of Bertha. Although the entire route for the megatunnel project had been studied and test samples drilled, the detailed geology of the construction area remained uncertain. The soil in the marked area was complex, with various compositions disrupted over time. As a result, the drilling was closely monitored. Since Bertha was a one-of-a-kind machine, navigating it was unpredictable. However, the engineers were determined to learn and adapt as they worked. In December, 5 months after the machine began digging, Bertha encountered a catastrophic failure that nearly halted the tunnel program. While drilling 1,083 feet into the earth, the machine struck a steel pipe and shut itself down. An inspection engineer had reportedly left the pipe behind while measuring groundwater. 3 days later, the situation worsened as the rubber seals around the main bearing failed, allowing grit to enter the machine's workings, which caused overheating. Despite efforts to get Bertha running again, the machine remained stuck 120 feet underground for 2 months. With no solution in sight, Hitachi, the machine's manufacturer, determined that the only way to repair Bertha was to dig it out and partially dismantle it. After months of legal disputes and inspections over the repair financing, the work was finally completed in December 2015, just days before Christmas. Bertha resumed digging, and engineers breathed a sigh of relief, but the trouble was far from over. While digging through a layer of stiff clay mixed with sand and gravel a year later, Bertha hit a section of the viaduct at 120 to 150 feet, causing a sinkhole to open up 30 meters behind the machine. Bertha was shut down for 6 weeks while the engineers filled the sinkhole. When the machine resumed work 3 months later, it continued drilling successfully for 11 months without further issues. After a final 6-inch course correction in March 2017, Bertha was ready to complete its mission. On April 4th, the massive tunnel boring machine broke through the reception pit's concrete plug, sending dust clouds into the air as media cameras captured the historic moment. While Bertha had made history, its journey ended in a bittersweet way. The engineers started taking apart the gigantic structure as smaller 40,000-pound sections that could be easily transported by road and used in other construction projects. Indeed, Bertha's accomplishment was historic for the United States and the global community, but it was not the only large tunnel boring machine the US concealed. There was another colossal secret the country had tried to keep hidden from the world. If you thought this was surprising, you'll be even more shocked as we delve into the secrets of a mysterious artifact-infused tunnel. But could this discovery rewrite history as we know it? Revealing the secrets of a mysterious artifact-infused tunnel.
Now to a much-needed upgrade for one of the nation's longest bridges.
A couple of weeks ago, the Chesapeake Bay Bridge Tunnel celebrated its 60th anniversary.
After Bertha, the United States was determined to improve its tunnel construction efforts, funding a new, secretive project. The Chesapeake Bay Bridge Tunnel project began in 2017 in Virginia, right after Bertha's completion, with a projected 5-year timeline to finish by 2022. However, multiple delays pushed the completion date back another 5 years. Amid these setbacks, the US introduced a new giant tunnel boring machine named Chessie, which started mining in February 2023. After tunneling about 750 feet, workers discovered large steel pieces on a conveyor belt suspected to be artifacts from a shipwreck over 50 years old. One piece was engraved with W.L. Byers & Co., a company that produced anchors between the 1860s and 1950s.
Centuries-old ship anchor which delayed the project for several months.
Despite the mystery of how the anchor got buried, Chessie encountered significant damage while tunneling through it. The steel caused grinding damage to the cutter head, requiring the replacement of 389 of the 442 tools. Repairs took more than 6 months, delaying the project by 241 days. But after the repairs, Chessie resumed tunneling, advancing about 50 feet a day, and by now, it has completed about 1,600 feet, approximately 25% of the planned 6,400 feet. The project is expected to finish in late 2027. Chessie and Bertha are impressive, but not the only tunnel boring machines digging through the earth. With advancements in technology, new types of TBMs are becoming more sophisticated. But do you know how tunnel boring machines work? How tunnel boring machines work? Tunnel boring machines, TBMs, are designed to dig tunnels deep underground with minimal disruption to the surface. Imagine them as giant high-tech moles. The front of the TBM has a cutter head, a massive rotating disc equipped with sharp tools that break through the earth, whether rock or soil. The debris, known as muck, is then removed by conveyor belts or slurry systems, ensuring the tunnel remains clear so the TBM can continue moving forward. In addition to digging, TBMs also build as they go. Behind the cutter head, concrete segments are installed to form the tunnel's walls. These segments fit together like curved puzzle pieces, providing a stable and secure lining for the tunnel. The machine places these segments precisely, securing them with bolts and grout to prevent the ground from collapsing. Steering a TBM is a complex task. Instead of using a traditional steering wheel, TBMs are guided by lasers and GPS. Engineers program the machine's precise path, and the TBM adjusts its direction using hydraulic cylinders that push against the tunnel walls. This allows the tunnel to stay on track, even if it needs to curve or go deeper. TBMs are designed to handle a variety of ground conditions. Some have pressurized chambers behind the cutter head to balance pressure and prevent collapses or flooding when cutting through soft soil, hard rock, or water. The largest TBMs can have cutter heads over 60 feet wide, big enough to fit a 4-story building inside. Despite their size, these machines are exact and can tunnel within inches of existing buildings without causing damage. So, how was Bertha, the TBM used in Seattle, different from others? Due to Seattle's complex underground conditions, Bertha was massive and faced unique challenges. Throughout the production, the machine was required to pass through various terrains, including loose sand, clay, and more. Furthermore, Bertha was designed and equipped to work under arduous conditions when tunneling in a densely populated city. The engineers faced manifold challenges, such as coming across steel pipes and addressing the breakdowns of some equipment to accomplish the task at hand. Nevertheless, Bertha had the most significant impact because it helped address the city's long-term infrastructure demands. Bell AZ 75710. Bell AZ 75710 costs about $7 million. The AT model is available in various sizes, with the smallest weighing approximately 180,000 pounds. In contrast, the largest model, the 75710, weighs 450,000 pounds, However, when overloaded, this massive machine can lift up to 1 million pounds. This gives the truck its Guinness World Record and another record in the car category by cubic metered measurement, which stands at approximately 645 meters. With the maximum load, the Bell Z75710 can carry a complete load of up to 1,700,000 pounds, equivalent to the weight of 2 Airbus A380 planes, the largest commercial aircraft in the world. This gigantic aircraft is almost as long as a football field, stretching to cover 20 meters in length, 10 meters in base width, and over 8 meters in height. It will be interesting to note that moving this truck is not a joke. The machine is enormous. The Bell AZ75710 cannot be moved by road. However, it has to be dismantled and moved around by 20 railway platforms, thus taking an entire train to ferry it. It is a truck with 2 engines and 16 cylinders, running 2,300 horsepower, therefore making 4,600 horsepower in the engine. The engines offer the same capacity and power output as nearly 100 mid-range car engines. The 2 engines' torque is at approximately 9,800 Newton-meter, 20 times that of Toyota Hilux. The 2 generators, which power the truck, churn 35,000 kilowatts of electricity. This is sufficient to supply 1,000 apartments, as each apartment may require nearly 3.5 kilowatt. Another feature that further distinguishes the Bell AZ is its electric drive system. It has 4 electric engines with 1,600 horsepower each, one for every vehicle wheel. The generators supply these motors and transmit the power to all 8 wheels. It has 8 wheels, and each wheel alone is approximately 12,000 pounds. Its diameter is 4 meters, and it is inflated to 7 atmospheres. Tire costs range from $50,000 to $90,000 depending on the model, equivalent to 2 to 4 economy class cars. If any of these tires burst, it would be similar to having 3 grenades exploding simultaneously. The Bell AZ75710 has a vast fuel tank containing 2,800 liters. This quantity is just 15 times larger than the Hilux's fuel tank. Even though it is gigantic, the truck travels approximately 100,000 kilometers annually and has an operational life of 10 to 12 years. It is an outstanding car intended for the heaviest work, which helps transport large quantities of sand and soil and work in various climates. The Bell AZ75710 operational experience, with over 620,000 miles on the surface, has been equally successful. Because it works in severe conditions, especially in dusty quarries, it has 8 air filters, which must be replaced frequently for refined performance. Originally unveiled to the public in 2012, the Bell AZ75710 is one of the 5 makers of these massive mining machines for use in applications with high work intensity levels. The giant is the Bell AZ75710, 10 meters long, 9 meters wide, and 7 meters high, with a maximum speed of 64 kilometers per hour, 40 miles per hour due to its size and power. It has a small cabin with 2 seats, an automatic transmission, 2 brake pedals, 1 accelerator pedal, and a cooling system to regulate the extreme heat it produces during operations. One of its massive engines runs at a steady 800 revolutions per minute, RPM, ensuring consistent power output to drive the electric motors. This steady engine speed, electric motor system, and rugged design allow the Bell AZ75710 to perform its demanding task of hauling hundreds of thousands of pounds of materials with precision and reliability. Suppose you thought the Bell AZ75710 was surprising. In that case, you'll be mind-blown as we delve into the colossal Le Tourneau L2350. But could this giant surpass everything we thought was possible in heavy machinery? Le Tourneau L2350. The Le Tourneau L2350 is the world's largest front-end loader intended to load minerals such as gold, coal, and copper ores into larger trucks. Made in Longview, Texas by Lerno, it uses 1 pound of meat per month, weighs more than a Boeing 737, and is 2 stories tall. It can lift 160,000 pounds, that is, 40 cars, and its 50 cubic yard rock bucket can accommodate as many as 5 regular dump trucks. The L2350, aimed at accommodating larger dump trucks, can lift 50% more than prior models. To complement this loader, Lerno collaborated with Firestone to design the largest tires, measuring 13 feet tall and over 5 feet wide. The L2350's frame accommodates a 150-gallon radiator. It is necessary to cool the turbocharged 16-cylinder diesel engine, which delivers 2,300 horsepower and requires 50 gallons of fuel each hour. When turned, this engine powers a generator that powers 4 electric motors, thus making the machine run smoothly. L2350, for instance, has huge hydraulic cylinders of 16 inches and can scoop all the material you want in the first few scoops, enough for an Olympic pool. This giant loader displays mining equipment that can meet the needs of the current mining sector. Caterpillar 6090 FS. The Caterpillar 6090FS is one of the most fascinating creations on this planet. This marvel of engineering is a mining shovel with an operating weight of about 2,200,000 pounds. To put it in perspective, it could carry over 1,000 mid-sized cars. Its large size and mass are testimony to the modern engineering and design that enable it to perform incredible stunts. Built with a 793 horsepower engine, the 6090 is capable of mining up to 122 feet deep and traveling 99,000 cubic yards of material each day, or approximately the volume of an American football field over 101 feet in a single day. His large capacity is suitable for large construction works such as bridge construction, high-rise buildings, and mining, among others. With GPS, 3D modeling, and auto control, the 6090 works swiftly but more economically than using much fuel and cash. Sensors and cameras give the operators an overview of the digging action, enabling adjustments to be made accordingly. The control of the machine is easy, reducing the operator's tiredness, while the machine's centrally positioned cab enhances visibility and comfort. As for servicing, it is also easy, with a central lubrication system and several points on the Civic for quick greasing of its parts. In addition to the above features associated with this dozer, another remarkable feature is that the Caterpillar 6090 dozer is a versatile machine designed for use in mining, construction industries, and demolition. Due to its size and output capacity, it is suitable for big projects and contains safety measures like the emergency stop button, fire extinguisher, and ROPS. Environmental features include emissions reduction technology. The centralized lubrication system minimizes oil spills and splashes, which makes the system more environmentally friendly. Overall, the Caterpillar 6090's size, power, and advanced technology enable it to handle tasks beyond the capabilities of smaller machines while maintaining efficiency and precision. Big Muskie. Big Muskie, the biggest walking dragline ever built in history, is even more elongated than 22 stories and weighs 20 million pounds. Largest and record-setting, it was designed for the Central Ohio Coal Company to dig deep into its enormous 110,000-acre mine for coal. The Bucyrus Erie Company developed and built the machine, and in 1969 it was ready for use after 3 years of research. To transport each component for the mine site, 340 rail cars and 260 trucks were used, and their assembly took 200,000 man-hours. These costs amounted to $25 million in 1969, approximately equal to $200 million in the present value. Another mechanical behemoth, Big Muskie, had a bucket size of 220 cubic yards or 170 cubic meters, sufficient to contain 2 ordinary Greyhound buses. The performance of this specific machine was estimated to have been raising 8,000 yards of overburden per operating hour, according to the information available in 1976. Over its service life, it moved twice the amount of earth excavated during the original construction of the Panama Canal. The colossal size of Big Muskie required substantial power to operate, equivalent to the electricity needs of an entire town. It was powered by 18 1,000 horsepower and 10 625 horsepower DC electric motors, drawing 13,800 volts through a trailing cable. This immense power consumption was comparable to the electricity usage of about 27,000 homes, making it extremely expensive to run. Special arrangements were made with local Ohio power companies to accommodate the machine's massive power needs, and the dragline operated primarily at night when electricity rates were lower. For instance, Big Muskie could transfer from one digging site to another on its hydraulic walker feet. It had a velocity of approximately 0.1 miles per hour and thus could only manage to travel a distance of below a mile. Big Muskie has been serving for 22 years, and in that time, it has moved over 600 million cubic yards of overburden and extracted over 40 billion pounds of coal, making Big Muskie one of the most famous pieces of mining equipment. However, Big Muskie ceased operation in 1991 because of high electricity costs and growing protests against strip mining in Ohio. For 8 years, Ohio did not actively implement the Surface Mining Control and Reclamation Act until 1999, which required all equipment to be removed from former strip mines for environmental reasons. Therefore, Big Muskie was dismantled at the site with the main boom, which was sold for scrap metal for $700,000. The only part of the machine that survived was its massive bucket, now displayed at the Miners Memorial Park in Bristol, Ohio. The site where Big Muskie once operated has been partially transformed into a wildlife park named The Wilds, which opened in 1994. The park is home to various African, Asian, and North American wildlife, offering a unique blend of industrial history and conservation efforts. Liebherr LR1300. The Liebherr 1300 crawler crane, with a 6 million pound lifting capacity, is the world's strongest conventional crawler crane. It has successfully lifted a 6,740,000 pounds test weight at its factory in Germany. Designed to lift its maximum load at a 12-meter radius, the LR1300 is ideal for power stations, especially nuclear plants and refinery vessels, where columns can weigh up to 3 million pounds and reach 100 meters. Each crawler stands over 3.5 meters tall and weighs over 400,000 pounds. The crane's maximum system length is 246 meters, achieved with a 20-meter main boom and a 26-meter luffing jib. The LR1130 operates without a derrick ballast, thanks to its in-house produced slew ring. With a derrick, it features an adjustable suspended ballast system similar to the LR1350, with a 20-30 meter ballast radius. A ballast trailer system is also available for transport. The LR1300 weighs 7 million pounds fully equipped, with 800,000 pounds of superstructure ballast and 3 million pounds of derrick ballast. Most components are under 3.6 meters tall and 4 meters wide. The crawler frames, measuring over 3.5 meters tall, 20 meters long, and weighing 420,000 pounds, are transported after removing the 164,000 pounds tracks. The 256,000 pounds frame is split and moved by a low loader. The 4.5 meter diameter sing ring is transported diagonally to fit within a 4 meter width, and concrete ballast blocks are designed to match 20-foot container dimensions. If you were shocked by the Liebherr 13,000 crawler crane, you'll be mind-blown as we delve into the Komatsu D575A3 Super Dozer. Komatsu D575A3 Super Dozer. Let's talk about the Komatsu D575A3 Super Dozer, the world's largest and most efficient bulldozer, nearly twice as productive as its competitors. Komatsu fully designed and built it, ensuring top-tier performance, reliability, and advanced features. All major parts, including hydraulics, powertrains, and frames, are manufactured in-house. The dozer is powered by an 858 kilowatt, 1,150 horsepower turbocharged and aftercooled engine, providing exceptional strength. Its large blade, with a capacity of 90 cubic meters, ensures efficient operation and reduces costs per pound. The blade's low resistance and the automatic lockup torque converter save fuel and increase speed during long pushes. The D575A3 also prioritizes operator comfort and control. Its PCCS system, Palm Command Control System, creates an ergonomic workspace. The travel control joystick is designed for easy use, allowing the operator to maintain a relaxed posture while operating with precision. Gear shifting is done with a simple thumb movement. The suspension seat can rotate 15 degrees to the right for better visibility, with transmission and steering controls moving along with the seat for added comfort. The seat and control console are adjustable for height and position, making it customizable to any operator's preference. The dozer uses advanced technology for smooth operation. The engine speed is controlled electronically, reducing wear and tear on mechanical components. Combined with Komatsu's reliable hydraulic system, the blade joystick allows precise and effortless adjustments. Its electronic powertrain system enhances performance by monitoring lever movements, switches, and sensor signals. It automatically adjusts clutch engagements based on conditions like speed and gear shifts, ensuring smooth transitions, longer component life, and a comfortable ride. The The cab offers a panoramic view through large tinted windows and is designed to keep dust out with an air filter and pressurized interior. Constant machine condition checks prevent major issues, letting operators focus on their tasks. With its unmatched power, advanced features, and operator-friendly design, the Komatsu D575A3 Superdozer sets the standard for large-scale earth-moving projects. When an error occurs during operation, the user code and service meter alternate on the display. A caution lamp lights up for high-priority issues, and a warning buzzer sounds to prevent serious problems. The fuel-efficient Komatsu engine and heavy machine weight make the D575A3 Superdozer a top-performing crawler dozer for high production tasks. The engine is designed to meet the EPA and California Air Resources Board's strict environmental standards. It features direct fuel injection, a turbocharger, and an aftercooler for optimal fuel efficiency. To reduce noise and vibration, the engine is mounted on rubber cushions. For long pushes, the lockup mode automatically engages the torque converter lockup clutch, transmitting all engine power directly to the transmission. This increases ground speed and improves efficiency, similar to a direct drive system. The design also ensures powerful traction, component durability, and operator comfort. The machine's track shoes follow ground contours for outstanding traction, while the X-shaped bogie undercarriage uses rubber shock absorbers to minimize vibration. This setup adapts to different surfaces, providing a smoother ride. The remote electric unit, REU, enhances suspension on flat ground and adjusts to uneven terrain for better performance. Standard features include travel speed presets, allowing operators to choose from 3 patterns: F1 R2, F2 R2, and manual shift. When a preset pattern is selected, the machine automatically maintains the specified speed, reducing gear shifting time during repeated trips. The auto shift function controls engine speed, gear, and travel speed. This means it must shift to the highest gear whenever the load is on, increasing fuel efficiency and productivity. In contrast, the Bagger 288, a bucket wheel excavator engineered in Germany that cost $100 million, comprises an example of ultra-large mining equipment. The Bagger 288 also earned the title of the largest land vehicle in the world by the time it was entirely constructed in 1978, even outranking NASA's crawler transporter used by the Space Shuttle and Apollo Saturn V rockets. With an estimated weight of 90 million pounds, this monument will be 95 meters tall and 225 meters long. This world's largest astronomical project takes nearly a decade to design, construct, and install. Standing 120 feet tall and weighing 70,000 pounds, it is still one of the largest vehicles on our planet today. The Bagger 288 is commonly used as a bucket wheel excavator in the large-scale mining industry. It was designed to dump overburden material extracted at this German coal mining site, particularly in processing Hambach coal deposits to the lignite. Per day, the capability can achieve mining equivalent to a soccer field to a depth of 30 meters, considering that the machine can excavate 8.5 million cubic feet of material daily. It can also process 530 million pounds of brown coal in 24 hours at its Stauber and Koenig open-cast coal mining sites. 4 belts transport the excavated material at a haulage rate of over 11.3 miles per hour. The thickness of each belt is 10.5 feet to accommodate a compact car. The Bagger 288 moves slowly, traveling at just 0.4 miles per hour on 8,600 feet of tread. It takes 3 weeks to cover a distance of 14 miles. Powered by 5,600 feet of thick electrical cables, the machine's total driving power is 3,360 kilowatts, comparable to 30 small sedans. Its massive bucket wheel, standing 71 feet tall, the height of a 7-story building, features 18 buckets, each weighing 7,700 pounds empty and capable of holding 23 cubic feet of soil, enough to fill a small cargo truck. Despite its enormous size, the Bagger 288 leaves minimal impact when moving over grass or soil, leaving traces no deeper than a human footprint. However, crossing rivers or long distances requires significant preparation. Its last river crossing cost $10 million, involving a team of at least 70 people to clear the path. While the machine doesn't need to move frequently during mining, transporting it is more economical on its caterpillar treads than disassembling and reassembling it at a new site. Currently owned by RWE, a major energy company, the Bagger 288 is part of a fleet of massive mining machines, some dating back to 1958. Its ability to move mountains of earth remains unparalleled as a marvel of engineering and mining efficiency. From America's secret drilling machine to the incredible feats of heavy machinery, these technological marvels are reshaping how we think about engineering.